All right, so this problem is problem 10.5.7, and in 5-card poker we have a straight, which is 5 cards of a consecutive denominations, so not all the same suit. We want to know how many ways are there to get a straight. Okay, so the first thing that we need to do is count how many ways we can start this. So we've got a 5-card hand, and the lowest card here could be an ace. And it could be anything from an ace to a 10. And the reason that we have to stop at a 10 is if you have a 10 in this slot, then it would have to go 10, jack, queen, king, and ace. And that would be the last place that we could start. Okay. So you can have an ace in this first slot. You can start with an ace. You can start with a 2, a 3, a 4, all the way up to a 10. So there's actually 10 choices, but there's 4 suits. So there's actually 4 times 10. Or in other words, 40 ways that we can start with this first card right here. So this is kind of like a restriction, okay? So 40 ways to do that. Now, once we've placed that, and let me give you a hypothetical here. So let's just say, I'll do the hypothetical over here. So let's just say that we had a 5 right here. And if that's a 5, then what's going to have to go in this slot? Excuse me, no multiplication there. This is just the 5 card here. This has to be a 6. This is already dictated by the fact that we have a 5 right there. So there's only 4 ways that we can get a 6. There's a 6 in each of the suits. So once we've placed this and we've counted that lowest card, there's actually 4 options for each of these next slots here. And that's because those are already dictated and we just have 1 card of whatever it needs to be for each each slot. But then we have 4 suits, which is why there's the number 4 there. Okay. All right, now, so this actually would calculate all of the straights. But they specified in this problem that we don't want straights that have that are all the same suit. Those are actually called straight flushes. So we're going to have to actually subtract off the straight flushes. And the way that we would calculate a straight flush is basically the same way, except that once we've counted this first slot right here, the rest of them are all 1. So let me give you a for instance again. With the straight flushes, if this first slot right here was, for instance, a 2 of hearts, then, and it's not a 2 of hearts, there's 40 different choices here because there's 4 times 10 different choices for the first slot. But let's just say that it was a 2 of hearts. If it was a 2 of hearts, then if this is going to be a straight flush, this has to be a 3 of hearts, a 4 of hearts, a 5 of hearts, and a 6 of hearts. We don't have any other choice for the rest of these. So this is all just, 1 choice as to what's going to be there. So to count the straight flushes, all we have to do is count how many starting places we have. Okay, so when I subtract off here the 40, then we can do this calculation and that will give us our number. And I believe that that's 10,200 is what that is, but let's check. Yep. So 10,200 would be our answer there. And that's it for that problem. Okay. Another related problem here, and I'll just make these one video since they're very similar. So this is problem 10.5.62. So we have in a 5-card poker hand, 3 of a kind is 3 cards of 1 denomination plus 2 cards of 2 additional denominations. And we want to know how many ways are there to get 3 of a kind. All right, so what we're going to do is calculate in a similar fashion. We've got a 5-card hand. So we want to talk about the ways to get three of a kind here. Okay, so if we're talking 3 of a kind, you're talking 3 kings, 3 queens, 3 jacks, something like that. So there's only 4 to draw from, and we're drawing 3. So for instance, if we were going to be talking about 3 kings, there's 4 kings in the deck, and so that's why we only have 4 to draw from, and we're drawing 3 of them. Okay, but that just counts one of them. So this would be the way to count the kings, or the way to count possibly the jacks or whatever. But we actually have 13 different ranks, so we're going to have to multiply that by 13 to account for the fact that this could be any of them. It could be an ace, king, queen, jack, 10, all the way down onto a 2. Okay, so 13 times the combination of 4 taken 3 will actually count the number of ways that we can get 3 of a kind in these 3 cards. Okay. All right, now these other 2 cards right here are going to be something else. So they're going to be whatever this isn't. So if these are kings, then we're talking about everything else that isn't kings. So that would be, we have 48 things to choose from, and we're choosing 2. Okay, now, however, this includes the full houses. So we're going to, again, have to subtract off a full house, because they did say here that they wanted 2 cards of 2 additional denominations. That means that it can't be, these 2 cards can't be of the same denomination. They can't both be queens or jacks or something like that, because that, when you have 3 cards of one denomination and 2 cards of another denomination, that's a full house. Okay, so we actually need to subtract off the full houses. And so the calculation for a full house is 3 cards of one suit, 3 cards of one denomination, and then 2 cards of another denomination would be a combination of 4 things taken 2 at a time, and we have 12 denominations left to choose from. And the word denomination here means the same thing as the word rank. So, if we think about ace, king, queen, these are each denominations, they're ranks. Denomination and rank are the same thing. So if I have aces here, I can't have aces here. So that means, I have 1 less rank to choose from. Okay. So your answer here would actually be 13 times combination of 4 taken 3 times the combination of 48 taken 2, and then we're subtracting this whole thing here, 13 times 4c3, 4c2 times 12. Okay. And if you do that calculation, I believe you come up with 54,912. And you could just be doing this in your calculator. So, I have a probability button. So if I wanted, for instance, to do combination of 48 taken 2, I would go 48, probability, hit my combination button, enter 2 here, and that's 1128 just for this number right here, and then you're multiplying and subtracting. You can also use the formulas, obviously, a combination of n things taken r at a time. It's n factorial over r factorial times n minus r factorial. But it becomes intensive to do that in a lot of these problems where there's a lot of calculations. So I just encourage you to use your calculator on these. Okay, that's it on these problems.